Motion is defined as the action or process of moving or being moved. As motion occurs, position changes. The rate at which position changes is speed. The rate at which position changes, relative to the initial position, is velocity. The derivative of position is velocity, and the derivative of velocity is acceleration. Speed is the absolute value of velocity. There are four primary equations, known collectively as the kinematic equations, which apply to problems concerning motion. Velocity equals position over time. The final velocity equals the initial velocity, plus the acceleration multiplied by the time. The final position equals the initial position, plus the initial velocity of the particle multiplied by the time, plus 1/2 the acceleration multiplied by the time squared. The final velocity squared equals the initial velocity squared plus 2 times the acceleration times the distance traveled by the particle. Remember that these concepts can be applied to an object in 2D when isolating either the x or y direction. Now that we've established that, let's look at some practice problems. A particle moves according to the equation x equals 12t squared, where x is in meters and t is in seconds. Find the average velocity in the time interval 1.80 seconds to 3.15 seconds. Because velocity is the rate of change of position, to find the average velocity, take the final position, subtract the initial position, and divide by the difference in time. Through this, we get 59.4 meters a second. B. Find the average velocity from the time interval 1.80 seconds to 2.20 seconds. The same logic applies here, but in this case we simply plug in different values and get an answer of 48 meters a second. A person takes a trip, driving with a constant speed of 95.5 kilometers an hour, except for a 30-minute rest stop. The person's average speed is 61 kilometers an hour. A. How much time is spent on this trip? The average speed is the final position minus the initial position over change in time, or change in position over change in time. From this, we can set 61 equal to the difference in position over the difference in time, and 95.5 equal to the difference in position over the difference in time minus 0.5 hours. Then we multiply and have 61 times the change in time is equal to 95.5 times the change in time minus 47.75. Thus, the change in time equals 47.75 over 34.5, or 1.384 hours. How far does this person travel? Here, all we need to know is that speed equals distance over time, and therefore distance equals speed multiplied by time. 1.384 hours multiplied by the average speed of 61 kilometers per hour equals 84.428 kilometers. Or.